Embeddings from visual language models are increasingly utilized to represent semantics in robotic maps, offering an open vocabulary scene understanding that surpasses traditional, limited labels. Embeddings enable on-demand querying by comparing embedded user text prompts to map embeddings via a similarity metric. The key challenge is that the robot must determine the parts of the environment relevant to the query. The problem of querying is to find the set VQ in the visual space of images or maps, given a query. As visual language models share a latent space of text and images, the problem corresponds to finding the region RQ in the latent space of the VLM. Most state-of-the-art methods implicitly estimate RQ by either thresholding the cosine similarities, which produces a conic volume centered on the query, or by comparing the embeddings to the query and a negative query, which splits the latent space into two by a hyperplane. Provided that the directions in the latent space have semantic meaning, we expect that the directions of the latent space have varying degrees of relevance with respect to the query, which means that the subset RQ is neither necessarily isotropic nor a connected space, reducing the effectiveness of distance-based classifiers. We argue that estimating the extent of RQ from a query and a negative query is not sufficient. To solve this problem, we propose QuaSH. QuaSH works by augmenting the query with a set of semantic synonyms and antonyms. Then, we train an off-the-shelf classifier in the latent space using these embeddings. If a nonlinear classifier is used, a nonlinear estimate of RQ can be acquired. Our method is not dependent on explicit thresholds, does not require expensive neural network training, and works with any encoder. We test our method on two standard image benchmarks, COCO and Pascal context, and use images from the mapping dataset as an additional benchmark. We show that our method yields improved results in image datasets, achieving a 15% increase in F1 score on COCO and a 9% increase in Pascal context. Additionally, we test our method in map querying. Our method yields a significant improvement when utilizing OpenSeg as the encoder, outperforming the baseline by 227% in F1 score. Furthermore, we conduct extensive ablation experiments on querying VLM embeddings, evaluating prompt engineering, negative queries, and the generation of synonyms and antonyms. Please refer to the paper for all details.